Live from all around the world, these are the Curious Bunch. From Zurich, Switzerland, Daniel Cvetkov. From Glasgow, Scotland, Kristina Kirova. From Lethbridge, Canada, Vasil Tudorinov. And from all around the world, a bunch of curious people. This is Curious Bunch. Hello, Curious Bunch. I am Daniel here, and we have Krisi on this side. Hi, Krisi.
Hey guys, good to see you.
We've been having some major computer issues this week, possibly mainly due to the absolute disastrous heat that we're having. Literally today, Chavo was supposed to join, but his laptop died yesterday. Like, it could not turn on. Apparently the motherboard died, and even today Krisi had some problem with her laptop as well. In the morning, she wasn't able to turn on her laptop for like half an hour.
And I live in Glasgow, and Glasgow is not famous for being hot.
Yeah,
It's insane. So guys, global warming is definitely upon us.
Yeah, it's happening. Yeah. Just today, this morning, we were talking with Chavo about some kind of controversial topic, like, what if we make like a nuclear winter? Like if we shoot all the rockets with the nuclear, if we start a nuclear war, the problem that everybody was citing before that is that we're gonna have a nuclear winter. Would the global warming and the nuclear winter kind of, make it livable?
I
What do you
guess,
think?
but that also means that you have to override all the other problems that are coming from a nuclear disaster.
Barring all the radiation that we've talked a few episodes back on our podcast about Chernobyl.
Go and watch it.
Yes, go and watch it.
In self-promotion.
Yeah.
Alright, so guys, as usual, I'll be answering questions, making sure that they are addressed. Unfortunately, we don't have a lot of people watching us, but that's an
It's very
opportunity
hot.
to be,
Probably people are just somewhere around the pools and just having a party.
I'm still even in the office actually. I'm not enjoying the only sunny weather, sunny day that we will probably get this summer.
Yeah.
So.
We'll probably make this
There it
a little
is.
bit short anyway, so you can soon
Yeah,
go
but we
and-
really want to show you something very amazing and kind of really, really cool that I have been using during my degree. And actually, it was Chavo's idea, but unfortunately, he couldn't make it to the podcast.
So what do you want to show us, or do we do the news, or do you?
Should we start? Let's start with the news.
Let's start with the news. I have news this week, and it's actually from previous week, and it's about the thing that I'm not going to change the frame. It's just I'm going to talk about it. So last week we didn't have time to prepare for this particular news as we already had one. But last week Elon Musk finally made some announcement as to what he's doing with his startup number 537, which is called Neuralink. What he's doing, for 2 years there has been some speculation. There is this very big, long blog post from Tim Urban. Tim Urban, you may have seen him on some TED Talks. He has a very famous one, which is called The Mind of a Master Procrastinator. And he's talking about how he has like a monkey inside his brain and sometimes it takes control. It's really funny. But anyway, he has this very long blog post describing what Neuralink is and the whole history behind it. And basically what it is, it's trying to implement a brain-machine interface. If you think like in generic terms, brain-machine interface is anything that you can connect your brain directly to a machine. Right now, we use our fingers and our eyes in order to input text into the phones or in keyboard on the computer. And we use our eyes in order to get input from the phone screen or the laptop screen. Or what he wants to do, and his company, Neuralink, they want to implant like a tiny cable inside of your skull and read the neurons from your brain, and you can communicate with with your computer this way. Now, it's not the first thing that it's not the first time that somebody has thought about this. We already have a lot of devices like this. For example, the cochlear implant, which helps certain um, people with hearing problems help them hear, or there's some visual implants which make people at least see a little bit and connects directly to the brain. And there's a lot of videos you can watch on YouTube and elsewhere about humans being able to control, for example, like a robotic arm with some fidelity. So it's not the first time that somebody does this, but his
Yeah, but I
announcement
guess it's
seems,
like the integration, like the whole
yeah,
thing.
he seems to increase the bandwidth so far. There is a cool live event that he shows a lot more details, and there is also a white paper, so you can guys read about it. It's quite interesting, but he has admitted in the beginning of the talk itself that this is not so much of a groundbreaking announcement as more of a hiring update. They want to hire basically the best people around the world to work on this problem because he believes this is a very important issue. And of course, like initially, he's helping people with certain disabilities, be able to communicate, and eventually, maybe this technology, if it's good enough, it can spread to everybody so that we are able to communicate with the machine. His visionary idea is that we should be able to have to stand a chance against AI. That's his big scare. So if we are able to communicate quickly with computers, maybe we stand a chance with AI, kind of augment ourselves. But that's like his, long term vision. Whether that will happen, who knows. So,
Hopefully
Chris,
it happens. I think
you
this is
read
quite exciting.
some of the blog. What do you think about the Wait But Why? How long did you?
First of all, I think the blog is amazing. I have to admit that I haven't read the whole article yet because it's huge. But I think it's a good idea to actually post in the show notes after
Mm.
that links to it. So maybe even I can refer to it. By the way, can you hear me properly if I'm staying
I hear you
away?
well. Yeah, I'm
Okay,
just
great,
monitoring the
cool.
levels. I'm trying to guess what they are, but I can never like precisely guess exactly how they'll turn
It's
out. So
alright.
sometimes I do corrections after that.
Yeah,
So we're good. So that's our
good.
news of the week. Well, it's
Cool.
previous week, but that's all we've got. There were not many interesting things around astronomy, and I mean, astronomy is going kind of slow. It's a big it's a
No, I
big
think
thing,
it's
right?
because I think it's because there's a huge latency between um, doing the measurement, especially in science in general. I think we
Mm.
touched upon this last week. There's huge latency, sometimes even years, between
Mm.
performing the experiment, getting the data, uh, writing the article, then getting published, and then going to the news. So
Mm-hmm.
sometimes it can be like 2 or 3 years. So even now, if we're like presenting a new, that would be, well, kind of an old
Yeah,
discovery
and
already by
also
default.
usually things are not so catchy, right? Unless we literally find
Yeah.
aliens in astronomy. Most news, most news about astronomy. Like I love astronomy, and I would love to have much more, exposure about this. But most of the news are well, we discovered another exoplanet. Yeah, we have like thousands of them now. It's not
Yeah,
really
but
news.
also you shouldn't. I feel like the general media and kind of what we consider news is something that it's like catchy title or catchy. Like most of the people care about aliens, but what push the science forward are those really really small things of like, for example, oh yeah, this planet is 1 degree away from what we would expect, and that's a huge thing, not because it's 1 degree, but because it's there's a flow in our expectation and models. I actually had a quick news that I wanted to mention.
Mm-hmm.
uh, you know that kind of all of the nations currently are heading towards space, so like either the moon
Mm-hmm.
or another planet or just somewhere away from earth, away from the
Mm-hmm.
heat, global warming and all that. So
Yeah. Yeah, that's
so
true.
it turned out that a couple of days ago, on 22nd of July,
Mm-hmm.
the Indian Space Organization
Mm-hmm.
has launched their mission to the moon.
Mm-hmm.
And they're actually going, they should arrive at the beginning of September.
Mm-hmm.
Um, on the moon, like a soft landing, and they're going for the South Pole
Okay.
because it's believed that on the South Pole there's frozen water. So they want
Ooh.
to investigate this bed of the moon, especially because, as you may all know, water is one of the main ingredients that we consider special for life, or like
Mm-hmm.
which can support life, and they're kind of um, important when we manage to discover them somewhere. So yeah,
No,
India is going
but it's
away.
big, right? I mean, I don't know if it's coincidental, but I mean, now that you mentioned it, last week we celebrated 50 years since the
Yeah,
lunar landing, like the first lunar
yeah,
landing.
yeah,
So
yeah.
yeah, that's also astronomy, right? Well, unless you
I
don't
actually,
believe in the lunar landing.
oh my God, don't get there. You know that the astronauts has actually left a lot of poop on the moon?
A poop, like
Yes, I was listening
human
to a podcast.
excrement.
It's just
Yeah,
I was listening to a podcast which is literally holy shit, and it's considered as well because there's
fun. Okay.
yeah. So like NASA has a very precise. Apparently, NASA has a very precise ledger of all of the
Mm-hmm.
human excrements that has
Yeah.
been left
That's
in the
that's what they should
space.
keep track of, right? No, but
Of course.
I mean, it makes sense. Makes sense. You have to log it. You have to know what is out there. Do they still
Yeah,
log it in the
because
ISS? Like, pro-
probably.
probably.
Oh, by
Okay.
the way, I have a question.
Tell me, or
Uh,
ask me, or ask the
do
audience.
you know? Okay,
Co-op
I'm gonna ask the audience as well.
50-50.
Uh, do you know? I've never actually googled this, and I have always wondered.
Let's see.
Um, when you're traveling by plane,
Ah,
and when you go in the
yeah,
toilet of
yeah,
the plane,
yeah.
and when it flushes, where
No,
does it go?
it goes into a container on the plane. It doesn't. So, yes, there is this big. I've read about this. There is this big thing that sometimes you see like plane trails.
Yeah.
It
Oh, if it's
some
like the yeah, yeah.
way. So it's several layers, right? It's several layers deep. So the plane trails that you see, they're known in the conspiracy theory worlds as chemtrails. So the
Mhm.
idea is that some planes leave these trails in order to, I don't know, manipulate the public or something. So they leave these chemical trails, which they actually go on the ground after they leave the atmosphere, the upper layers of the atmosphere. So they manipulate everybody, with some secret chemical compound, whatever. This is an
That
interesting
sounds
topic.
legit.
Yeah, we can talk about it like sometime of what are they actually, or like in general, what conspiracy theories are there and what the actual truth is. And then at some point, while I was researching that, there was also, of course, this question, like what happens to poop and like human excrements in general, because some people have actually seen some blue stuff falling from the sky when airplanes pass above them. And they were all thinking that, well, maybe it's the chemical toilet is just discharging about that. No, it's not. It's just stored on the plane. Some random shit happening somewhere, but it's in general it's just stored in a container, and then when they unload and load the plane again, they put a pipe and they do the thing, and it's just it's not that heavy, so that they have to like leave it. But
Nice.
planes do have
By the
dumping of
way,
fuel.
okay, okay.
Just one last thing. Planes do have dumping of fuel when a plane has to emergency land, and they need to get if they have if they have to emergency land. Usually planes are loaded with a certain amount of fuel, so that they can survive the whole flight. And if they have to land emergently, like they have more fuel, a lot more fuel than they would have if they had to like go the whole way. So for example, they have to like emergency land after 10 minutes or half an hour, 4 hour or 8 hour flight. So what they do is, if they have the time, if they could do it because it's safer, they go around like several times before actually landing, and they dump the fuel. And there are areas, there are designated areas where they can do this, and then they land. It's not gonna kill
Okay.
necessarily the plane, but it's much more dangerous because of the whole weight. It can crash the plane or something. I don't know. But it's a very interesting question. So Yeah,
Okay, I didn't
things
know.
things
I
do
just
fall
wanted
out of the
to
sky. Yeah,
I just wanted to acknowledge the fact that we have Physica Universalis. I'm sorry if I'm not pronouncing it properly.
yeah,
Um,
sounds Latin.
which says that they actually knew the answer that it stays on the plane.
Yeah.
And also they had a question. Well, they had a comment
Mm-hmm.
about that the problem with nuclear winter, going back to
Mm-hmm.
the nuclear winter, as climate control is that it's probably going to destroy the ozone layer.
Okay, yeah,
I mean,
that's gonna
it's
be
not
it's
only
gonna be one of the problems. Yeah, yeah,
Uh, yeah,
yeah.
okay.
I mean,
So
definitely ozone
I think
layer,
we're done with the
radiation.
new.
By the way, you say
Getting
new
there.
as if like the singular of news is new. I don't
I
think
don't think there's a singular.
I don't think the singular of news is new. I think it's still news. It's a singular news, plural
Maybe
news. I
there's
don't
no
know. I have no
singular.
idea. We're not English
Did I
speakers,
say
whatever.
it?
Yeah, but or maybe I hear it that way. Whatever.
Could be. I mean,
Okay.
I can always say, "Oh, I'm not native."
Hi, Kaoyang Gang has also joined. I don't know what he means by Dani 2019. It's
No, I
just
think he's
my new
quoting you. No, he's
hairstyle.
quoting you. That the
Oh,
place needs to survive.
yeah. Well,
I mean, their own half light.
some Boeing airplanes have some troubles, so you know it's still news. Anyway, our main topic for
Anyways,
tonight. Main topic for
is
tonight.
Monte Carlo
What
simulations.
is that? Tell me.
I don't
Ah,
know.
what is that?
um, so it's a thing that has been bothering me for my whole third year, I guess, or
Bothering.
four.
Okay. So what is it? I know
um,
Monte Carlo is like a very famous country which has a lot of casinos. Does it have anything to do with that? Do you know?
I think it has. Actually, it has.
Yeah.
It's named after the city slash country
Mm-hmm.
because it has to do with, when you go to the casino, it's more or less, sometimes it's random. Like you have some probabilities, you need to calculate what's go. Oh, sorry. You have to, if you want to be a professional player, you cannot just leave it all to luck or
Mm-hmm.
cheat or something.
Are there like professional
So,
players, like professional
I think they
gamblers?
are, but anyways. Oh, sorry.
I don't think you can win
Well,
against the casino. But anyway, on.
anyways, so every time we are trying to measure, to do some statistics, to measure some stuff, we, and well, in general, our life is about predicting and about telling what's gonna happen
Mm-hmm.
in next week or in a month or something. For example, even the forecast, it's a way of predicting the weather. And because the weather is such a complicated system with a lot of variables, you need to run a lot of simulations. So Monte Carlo is the name of a simulation which is using randomly generated data points, and it's really really useful, and especially during the um, maybe, let's say, don't quote me on that, but like in the last 30-40 years with the development of computers, it has
Mm-hmm.
been the main way of predicting and studying pretty much everything,
Okay, so
because
what did we
computers
have
are
before
great.
that? Did we have like palm reading and throwing beans and looking at the spherical?
We still have it though,
We still have it.
but I
Is
mean,
it how much more accurate is it than
much more
reading my
accurate.
palm or like reading the stars? You know, we have astrology as well.
Oh yeah, don't get there. By the way, I think I lost the sound. What did you
Oh,
do?
sorry.
Oh yeah,
Yep,
okay.
go on. Yeah.
You just mute me, right?
No, I muted myself somehow. This this
Oh yeah.
this interface keeps changing and yeah. Okay. Now you should hear
By
me.
the way,
Go
Koyan
on.
Genkov says
Yep.
Monte Carlo is a fancy name for just saying screw it, I'll just go random and average what happens.
I
Yeah,
had an
more or
observation
less.
today as I was reading the topic and I was trying to understand what exactly it is because I've heard it many times before, but I didn't know exactly what this thing is, like Monte Carlo, whatever. And I knew it's some kind of random sampling, but I knew nothing more than that. But as I read more and I was reflecting on it as I was thinking about it, I was like, isn't that the whole physics pretty much? Isn't that how we do any kind of measurement, any kind of like because we're like okay, from what I understand and like you can correct me. Monte Carlo is basically you don't know what the probability distribution is of something, or you have a guess but you don't know exactly what kind it is. So
Yeah,
you kind of
yeah,
try to random sample it, and you like the more points you sample, the better approximation of like the curve becomes. Like you have like some bars and then
yeah,
they
yeah,
become
yeah.
like a smooth curve, something like that. Maybe we'll show some
Yeah.
examples after that. Right.
Mhm.
But isn't that what we do with physics as well? Like basically we don't know the probability distribution of the universe function if something like this exists. I imagine I've heard about this, wave function, so I imagine it's something correlated with it, whatever. But basically, we don't know what the function of the universe is, and we make a lot of experiments, and every experiment shows a little bit like we're peeking a little bit at the universe. How does that sound to you? Very unscientifically, but maybe
Yeah, I think
philosophically.
it sounds, yeah, it sounds very philosophically, very beautifully described of like, yeah, we're just running simulations, which is kind of true when you think about it. Because
Hmm.
I've always I really like this example of
Mm-hmm.
like, yes, we have accepted that the laws of gravity and the Newton's law and they all work, and they were like, yeah, sure, this is a law, this is a statement. But the fact is that you have no, you don't have a good way to
Prove
like
anything.
basically you observe it that it happens every single time when you drop an apple, it falls
Mm-hmm.
to the ground,
Mm-hmm.
and we have the mathematical equations to describe this motion. We can account for friction, we can account for initial velocity, we can plug into the equation and solve it. But maybe once in 1 milliard years we won't observe what
Mm.
we are supposed to. And this
Like
is
we have very
actually,
strong predictional formulas which tell us most likely what will happen, but we can't really predict the future in a way.
yeah, because it's not, because it's based on, more or less it's based on observation. Basically physics is observing the nature and trying to make predictions based on your observations. Maybe I'm oversimplifying this. Um,
So
but for
Koyan
example,
said that
maths.
that
Yeah.
the experiment's usually not so random though, and I'm not sure the analogy is very good. Okay, I'm not talking about any kind of measurement, but imagine, for example, you're trying to measure, the mass of the Higgs boson, right? What we do is we do a lot of like I barely read it today, so I might be completely off the like ballpark of explanation of what that is. But we make a lot of probes at the energy levels which we think they are, and we can't really control like how they'll collide and what exactly will happen, but like we can sample from it and we can build like a distribution of like where it is likely that the Higgs boson lies within certain error
Actually,
bars.
I think I actually have those graphs, or like I can show it because I was doing something similar. Let me.
Okay, if
Yeah,
you
but
can
like,
share the screen.
yeah, but first I need to find it.
Okay.
Um, but yeah, I think you're. Actually, the funny thing is that Chavo suggested this topic, so
Yeah,
he was supposed to be the expert.
but he's
So,
not here, so we're trying to do our best or worst. Try to understand that.
uh,
Yeah.
hmm, so let's see if I actually have something.
Okay.
Um,
I have something that I can show in the meantime while you search for it. I'll
okay,
try to
yeah,
bring the
I
screen
found it, but
here.
yeah, it's fine.
Hopefully, I don't have a double voice, but who knows? Like, if it happens, if I have a double voice, just let me know. Right, but this is a website that I found today while I was looking at this. Let me just check really quickly if I have a.
Oh,
Maybe. Okay. So Yeah, I just checked if we have a double voice, but I can't really because it's
No, it's fine.
whatever. Okay. Anyway, so you can see here that it's a website which shows you like why you shouldn't go to the casino, like why it's a bad idea, and it's kind of a pun because Monte Carlo is famous for casinos, right? So we have, for example, a program which is written here in Python, which tells you what happens like if you just throw a random coin, and you can run it many times, and somehow randomly it gives you a heads and tails. And then I went into the rabbit hole of actually trying to research what does it mean random? Like how do we draw a random from a computer which is supposed to be a predictable thing, right?
It's not random. It's not random.
Yeah, it's called
There's a seed.
yeah, it's called pseudo-random, and even the
Yeah.
seeds is like it like I knew about this, but I read a little bit more about it, like what exactly formulas are running it, and it's just fascinating, like to actually understand that. Anyway, but for all practical purposes, from our perspective, it's random, right? So it's not really random. Oh, and like when we're talking about random, there is of course this website called random.org, which is actually random. So what you can do here is it like if you read about this, it gives you it somehow measures the atmosphere noise or something like that, and it generates real random numbers. So when I click this, it actually generates random, not pseudo-random number, or at least as close as we know from universe entropy sources. Anyway, going back now,
Okay.
this is like if you flip a coin, you know, any number of times, and you can write them down, but this is just tedious, and computers can do that. So here we say we flip a coin 1,000 times, and this is how many heads we get and how many you know, the rest are tails basically. So this is basically a program that counting, you know, how many times. And this is like the introduction of like Monte Carlo, because like basically you just make the computer do your experiments many times given the probability distribution in a way. And the probability distribution for a coin is basically 50-50 for like for a fair coin to get like 500 tails, 500 heads. But of course, getting exactly 500 tails and 500 heads, it's less likely, I think, but I don't remember why. There was mathematics behind it, whatever. And then, of course, if you run it 1,000,000 times, you get a different distribution. Okay.
No, but the point is that it's close to 50%.
You're getting closer and closer to 50%.
Yes.
Yeah. Right.
So that's the beauty of it. The more points or outcomes you have, the better your like the high the narrower your peak is.
Mm-hmm. I just
So
tried
I can
switching.
actually
Yeah, go on.
show- yeah.
Mm-hmm.
Should I?
Yeah,
can I actually
if you
show a
share,
quick
yeah,
example, yeah.
yeah, you can share your screen, and I'll bring it here.
Okay, give me a second. Okay, cool. Okay, that's gonna be fun.
Oh, okay.
Yeah, I know. Sorry.
I'll be in the bottom right corner, or do you want me somewhere else?
Mm,
I can be in bottom.
I cannot see, but whatever you put yourself.
Yeah,
Um,
I can just remove myself.
the funny thing is that I did this first and second year, and it was in Python, and then in third year we did something very similar in C, because C is much faster. But I'll show the Python first because there's like a nice graph. So
So what is that? If you can explain it first to
yes,
people
of
who
course.
don't have any idea.
Yes, I just wanted to bring the other code that I'm gonna actually run.
So this is in C++, right?
Yeah, but I'm gonna run the Python one first.
Okay.
And I'm gonna open it with Notepad because, come on.
Okay.
Okay, so basically, what this thing does is evaluating the number pi, which is kind of out of nowhere. Like okay, you're generating some points and then, poop, you got pi. Awesome. Like how awesome is that? How it runs? It's basically on a. Let's say you have the unit circle, but also the unit circle would be like identical in the 4 quadrants. So actually what you do is you take only the first quadrant, and then, by the way, am I on the screen?
No, you're not on screen. So I'm
Okay.
just listening to you.
Okay. Anyway, so I'm just gonna
You
show
can
the graph
open like
again.
paint or
No,
something?
it's
I don't
fine.
know. Is
No,
there?
it's fine.
And you can draw.
So basically, this is what it produces. So on this graph,
Mm-hmm.
each point has been randomly generated. So in the program, in the code, you basically said, give me a coordinate for x, which is somewhere around here between 0 and 1.
Mm-hmm.
Give me a coordinate for y, which is again between 0 and 1. And those two coordinates are corresponding to a point, for example, this one.
Mm-hmm.
And then, very simply, if you have x squared plus y squared, which is this distance, square root
Under
of
square
this.
root. Mm-hmm.
Yes, yes. So basically, when you get this distance, you can compare it to 1. So, obviously, if this distance is more than 1, this falls within the circle. If
Mm-hmm.
it's bigger, it falls away in
Mm-hmm.
this blue area. And the more points you generate, the um, the better. Basically, each point is like a sample. Each point
Mm-hmm.
is sampling this plane. If you just generate 2 points, then maybe both of them will fall within the circle, and you'll be like, okay, everything is within the circle. Like with 2 points, your guess is very bad.
Mm-hmm.
With 2000, it looks something like that, and you can clearly see how many points you have within and how many points you have outside.
Okay,
And
but
how
I
is
didn't
this
get.
related?
So what you have is you have the distance from the point to the origin,
I can
right?
bring
So
the
this is
code
r.
again. Yes, so this is r basically. Like
Okay,
square root of x squared, y squared, if it's
sure.
bigger than 1.
And this part of
This
the code
is.
is actually just plotting them on the graph, right? This is what it's doing. You just plot, right?
Yeah.
Yeah.
But I mean,
Okay.
I'm generating them here. I'm just saying x is random
Mm-hmm.
and y is random.
Sure.
Again, what random means is,
Whatever.
oh well,
It's
yeah.
pseudo-random. Okay, fine. But you get x, you get y, you find r, which is the distance from the point to the origin. That's easy. Pythagorean
Yes,
theorem, blah, blah,
yes,
blah. Fine.
yes.
So what do you do after that? You have r.
I compare it to the radius of the circle that I have
Okay.
established,
Uh-huh.
and in this case it's 1, just because I'm on the unit circle.
Right. So basically the radius of the circle that you draw is 1. That's what you decide. Yeah. Okay.
Yes.
Mm-hmm.
And also, as I explained, I'm just using the 1/4, and then I'm just multiplying the area by 4, because, well, you can play around with this, because if you have more area, in order to sample it better, basically, ideally, you want to have the samples as close as you can get them. And if you have a bigger area, then you need 4 times bigger amount of sampling points. But because they're identical, you don't like in this particular case. It's much better to generate them just in one of the quarters and then kind of extend this result.
Wait, so from what I understand from the code, you have k, which is equals to the length of the array, in which, so what is x of a here?
Oh, sorry. So k is the number of points which were within the circle.
Which are in the bounds of the circle, yeah? Mm-hmm. Okay.
Yes, and n is the number of points which are
Which are
initially
overall.
generated. I'm just gonna run the code again so you can just see.
No, but yeah, okay, run it. I'm trying
I'm
to
gonna run
understand
it from the
that.
terminal because I'm super cool, because I
Yeah.
just learned how to do it.
That's good. Let's see if you can actually show off now.
Yeah, right.
So in the meantime, I'm trying to still understand. So can you move your terminal to the right, just so that you can still see the code?
Okay, don't look at my code. I did it
I want
like
to.
2 years ago.
It's good.
Like,
It's good. Come on. I'm trying to understand the maths behind it. I'm not judging the code. It's fine. So what you have is XA and YA, and how do you decide if they're within? Oh yeah, you decide if they're within the circle, if they're
Yes.
less than 1, if R is less than 1. Is that what is happening?
Yes.
Okay. And this is the line A equals NP where NP dot square root blah 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 is less than 1, right? So NP is, because I don't know NumPy, but what I guess it's like a function which filters for an array for which x
You're
and
asking
y are
for
less than 1. Okay,
yes.
I got
You're
it.
asking for numpy where, right?
Yeah, so it's like a
Yeah,
filter
it's
function.
basically performing. Yeah, it's basically casting. Oh, it's doing a lot of things under the hood. But
Oh,
it's
wait,
basically casting.
I understand. So x equals np random random, this is actually generating a random array of n elements. Is that
Yeah.
right?
Mhm.
Right. So like this array of x is gonna be numbers between
Yes.
what is it, between 0 and 1? No. What are these numbers gonna be? Oh, the x coordinate that you give it, right? Between 0 and 1. Yeah, because that's your unit circle. And then y is going to be an array between 0 and 1. And then np where is a function that that filters.
It's a function which filters, but and in the brackets you can see that x squared and y squared is actually under the hood is squaring each value of this array.
Right.
And it's
Yeah.
squaring each value of the other array, and then it's summing it up, and then
I got
it
it.
compares each of the values to one, and it's like it's doing so many
Yeah, it's
things.
cool.
Just,
No, you can
like
just
that.
like in Python. In Python,
Yeah.
it's really cool because you can override things. Like you can override the plus
Yes.
operator. In this case, what they're doing is they're overriding the power operator, which is the double star. So they're overwriting the star operator, which expands it to the list object, and then they create the A, which is an array which is already filtered. And if you compare the length of the array, which is, I'm not sure though why do you call x of A? Like this part. So length of x of A, isn't A itself the array that you need?
It's the A is the array of zeros and ones where you have yes or no kind of, and then x of A is only the points that are within this. Well, in this case, yeah, within the circle. I don't really need B actually. I think it's just a. I think I did this B. What is outside is just for the porting function.
Okay.
Yeah, so like those lines are to make it red and blue. So like this is how you mark all the ones which are inside, outside, and this is how
Yeah.
you mark all those like.
Okay.
Yeah, so this is inside, this is outside.
Can you run it so that we get the
Yeah,
satisfaction?
I just
'Cause
want
think
to.
people are.
Yes.
Okay.
Okay. Yeah, I'm like you're getting too much into the code.
I just wanted to know.
So yes, of course, because you're a curious bun, right?
I am a curious one.
Aww. So it prompts the user for enter a number of random points that you want to sample. Let's do it only with 10, so we can see how bad it is. And then you get that within the circle, outside the circle, and you got that our estimate of pi.
It's 3.2.
Sorry,
Okay.
area. Yeah, it says area of the circle, but in this case, it's actually pi as well, because
Right.
the area is, for those who may know, the area of a circle is pr squared. But we just chose for simplicity to have r equals 1, and
So
1
it's-
squared is 1.
Is 1, so it's pi.
So the area of the circle in this case, in this particular case, is the same as the number pi.
Okay.
So you can see that we're kind of close. It's not too bad.
Can you show actually
But on
the
the
PDF
graph-
generated now? That those got
sorry,
generated?
That's another one. Yep.
Yeah.
Just give me a second.
Mm-hmm.
Okay. Oh no. Oh no.
No, this is another one.
Yeah, this one. Sorry.
All
Yeah.
right.
So those are 10 points, and they're quite random. Actually, and now if we generate this again, we can actually see that the points are different, hopefully.
Well, if the random
Let's
works, if the random is the same, then
If it doesn't, it's gonna be so fun.
Right. It should.
Right?
should.
Yeah.
Yeah. No, but it probably won't
Okay.
update the window itself, right? So you'll
No,
probably have to.
it should, it should, it
Does
should.
it? Okay.
Let's
Yeah.
try it.
Oh, yeah.
Okay. Um, let's do it with 10 again. Okay. Yep, it updated.
Oh, cool.
So now we have. Now it's pretty bad because we got 9 out of 10 points inside, and
Uh-huh.
this tremendously spoiled the value that we got.
Mm-hmm. Do it with 26 now. I want to
Oh
see.
god, okay. Of course it's 26.
Yeah, we have a thing in
That's an
astronomy.
inside joke, yeah. Okay, so it's getting better. No, actually not really. It got 2.9. Ah,
Ah, so why
so
did it become with more points worse? Is it just chance?
it's yeah, it's just chance. It's like actually yeah, in third year we had this like a similar assignment as I mentioned, but it was also okay. Get a graph of what the number like if you increase the numbers of points, how would you increase
How
or
accurate it
sorry
becomes.
decrease? Yeah, yeah. How
So
you would you decrease the error?
is that in a way a Monte Carlo of Monte Carlos? Because you run a lot of
Yeah, kind
experiments of
of.
Monte Carlo, sampling the Monte Carlo, right?
Well,
It's
not
Monte Carlo
really,
square.
because when you're running the experiment, it's kind of you're running in consecutive, like
Yeah,
you're running
but
with 10, you're running with 20.
you're sampling, right? Because you're sampling with different sizes of the distribution, and the distribution itself is calling random, so it has some kind of random property, yeah?
No, I'm not calling the distribution random. I would hard code it to be 10 points, 20 points, 30 points.
Sure, but you're
If I
iterating
call
over
it
those.
random, yes, but I have iterated over known values. So that's the subtle difference. Anyways, so because I want to show something else, so let me progress with this one. Let's go for 2,600 points.
2,642.
Oh god, okay. Now we're getting picky.
Yes.
Okay. Now you can see that it takes much longer, but it's much more accurate. We literally got the first like if we run it with just once again with just a little bit more, like 10 times more, just for the sake of it. Okay. And now it's gonna take ages because my computer is slow.
But now it's gonna be almost a full colored because you tried with 10 points now. It's gonna,
Hopefully.
yeah. Okay, but what value did you get?
Yes, amazing.
All right.
Well, we didn't get much closer. Oh well.
Okay.
But it's pretty.
Yeah. Okay.
So yeah, that's one of the applications. Obviously, this is an application that nobody really uses currently because we all know pi
Of course.
pretty well.
So Koyan just asked me about how many digits do I know from pi. Around
Oh,
150.
no. He actually knows a song about pi, and
I can show
let's
the
not
song.
sing it.
No, I can show the song. It's okay.
Okay, you can show it, but not. Yeah, okay. Maybe you can stop sharing my screen so I can.
Yeah.
Or-
But I probably won't be able to actually play it. So let's just get us back on screen. Hi. But there is a song that I'm trying to search for now, Pi song. But there's so many Pi songs now. Oh my god, YouTube is exploding. There's so many Pi songs now. There used to be just one, of like, yeah, whatever. It's hard to find.
Okay,
I'll
in the
find it and I'll
footnotes.
show it in the corner. But it's basically like a song which sings pi with the numbers, and it's about a minute and a half long or something. So when I was like in 8th grade or 9th grade, something like that in high school, I just listened to that song 1,000 times on repeat very quickly. And so I memorized it, basically just from repetition. That's what I would do for like 2-3 days in a row and just stuck in my head. Because it has a melody. It's a stupid melody. It's this kind of electronic fake melody, but it's still a melody. I don't know where the origin of the song is itself. I have no idea, but I'll just give a sample. So it's something like 3.141592653589793, etc. But like it goes up to like 140 or 50 digits, something like that, and that's how I know it. So it's
I'm
completely useless.
impressed.
Don't do it.
Yeah, I'm like, and you're the person who doesn't want to memorize anything.
I know, but pi, it's cool. And I'm known as pi squared, which is a different constant, and it's close to 9.81, which is also interestingly very close to the gravitational acceleration. Do you know why, though? It's very close to the
What?
gravitational acceleration of Earth, pi squared.
Actually, no.
It's homework. Think about it.
Oh, okay, okay.
Because
and it's
pi
not homework
squared,
only for me; it's for the other people as well.
yeah. So pi squared, if you get this value that Krisi just discovered from, so what was that called again? Needle, something like this.
No, that's
Other than
another thing. I wanted to show the needle as well. But yeah.
what is the thing with the needle? It was similar though, right?
Yes, that's another way of calculating pi. It's
Okay.
by, it's actually according to, it's an experiment which you can perform on a piece of paper, which is pretty awesome because like on a piece of paper with a needle, you can get pi. How awesome is that? But currently we were actually simulating it on a computer because you can toss maybe like 50. I can see that I have done it with 50,000 needles, which is pretty awesome, and it's running very, very quickly. And again, the idea is to, because the way the needle lands depends on the angle, and you're trying to see if the needle, when it lands, you have like you have some lines, like equally spaced lines, and you're throwing some needles and throwing, and based on the
Just
angle,
dropping them, or do you spin them?
just dropping them.
Just dropping them.
And based on the angle, like the angle would, based on the angle, you know if the needle will cross the line or not, and then basically by counting how many needles has crossed the line, and comparing them to all the needles, you can get the angle. And what Kauyan mentioned is that one of like the easy way is to use a tan function,
A
but
what?
this is a tangents,
Okay.
arctangs.
Okay.
But this is the like the cheating way, because basically tan already uses the properties of pi and all of that.
Pi. All right, just to display for the audience what is meant, as far as I understand as well. So you have this paper on which you have lines. These lines are approximately the length of the needle or something like that, right?
I think they need to, yeah, approximately, yeah.
Right, and then when
They
you
need
throw...
to be a little bit more, yeah.
Okay, so, sorry. When you throw a needle, it lands in some of these configurations, for example, right? This is a crossing, this is non-crossing, this is crossing, something like that, right? And then you count how many of them are crossing, the lines and how many are not, and some proportion of that, I don't understand how, but some proportion of that correlates somehow to pi, because there is some kind of rotation when you spin the needle itself, right? So it falls. But I think you have to either spin it or like don't look and just drop it, because otherwise if I drop it like this, it will always drop, kind of in the same direction.
Of course you don't look. I can actually, can you share the screen again, please?
Your screen, sure.
Yep.
Well, first you have to share your screen.
Yeah, sorry.
Yeah.
Okay. Oh.
I think you're stuck.
Cool.
Okay.
No. Okay.
Good.
So I'm actually I'm bragging here a bit.
Go on.
But this is my this is a report from the first semester in third year, and it's called "Simulating of the Performance Needle Problem." Actually, one of the people watching us has done the same project, so it's quite fun. So it has been suggested in the 19th century as a just kind of a thought experiment, but then some people actually went and performed it. And this is the math behind it. It's like about probabilities, and then you get this nice expression from where you can get pi. I'm not gonna
Hmm.
get into details because it's a
I'm getting
report
interested
and
in
it's
the
not the
detail.
main. I know that's why I'm like I'm not gonna get into details. Don't ask me. If
Okay.
if some if some people are curious, I can just send it over. I don't care.
Hmm.
Um,
You don't care. So curious bunch. Okay.
no, I mean I don't care about my personal. How is it called?
Report.
Okay, no, like when something is your piece of work, you know,
Property. I don't know.
like kind of.
Intellectual
Anyways,
property. IP. Yeah.
intellectual property, intellectual.
Yeah.
So
Okay.
yeah, this is basically how um, accurate you get by the numbers of single experiments.
Hmm.
So this is the and you can see that with more needles you get more
But
accurate, and
is
it's
that
also
again
random.
like Monte Carlo in a way, or how is it
Yes.
different from?
This is definitely Monte Carlo, yeah.
Hmm.
Because you're simulating random stuff, and then based on the random x and y, you do some stuff, you calculate, and then voila, you got pi. And
Hmm.
this is actually this graph shows how nicely it converges to the real value.
Hmm.
So the more needles you have, the more it's gonna converge towards the proper value.
Hmm.
Um, yeah, and that's the same graph, but just um, like flipped. And there's like, of course, error analysis, uh, sigmas, best fit, and all that. Like this is the
Right.
error bars. Um,
Beautiful. You have
but
a
yeah,
lot of
yeah,
beautiful
it's
things
pretty
and
awesome.
code as well. I see.
Oh, my code is so full.
Yeah.
Uh,
I don't know.
but thanks.
I mean,
That's why I skipped it. Oh, sorry, I need
you're
to
doing
stop
a
sharing. Yep.
inception
Oh
of
God.
lives. Yeah.
Okay.
Okay.
Right. So those are the like very basic examples. Also, another example that's actually useful currently. Um, it's for integrating purposes. If you want to know the integral of a very nasty function, and integrals are used everywhere basically, like mainly in physics, but for a lot of other purposes as well. So if you want to have the integral, and you and it's not a standard integral, it's not like oh, give me the integral of x squared, um, that kind of thing. You basically have to simulate it. So you basically have to have a computer,
Mm.
which is getting random points in some interval. Say if you want to find the integral between -1 and 1, the program will generate 1000 points, calculate the function, and then obviously there's different methods of if we're gonna calculate the middle of the bar, or like the right hand side or the left hand side. Like there's different optimizations depending on what kind of functions you would generally expect.
Mhm.
um, but yeah, this is how you basically solve integrals. This is what Symbol Lab and like Mathematica and some other mathematical slash physics softwares does under the hood. They're using
Cool.
Monte Carlo in a way. Not only, but
Mhm. I think
yeah,
we're reaching the point where we need to
cut it
finish
off.
the conversation.
Okay,
Yeah.
last bets also.
Okay.
It's not only for physics and maths, it's actually all of the financial companies are running Monte Carlo simulations to predict the pricing of the markets, to predict the credit values, to know what's gonna happen. Um, Basically, if you're getting, well, broadly speaking, if you're getting a credit, there's a huge chance that somebody somewhere is running a Monte Carlo simulation to determine how much you have to pay and what is your um, overdraft limit and all of that. So Monte
Mhm.
Carlo is everywhere. Yeah, which is inspiring.
Cool. And I think
Pretty cool.
it's more than just these kind of simple things. As I was doing my research today, I found that it's applied also to graphs and some kind of state machines theory as well. And it's something called Markov chain which I've heard, I think, last year when I was doing the research about Bitcoin and stuff. I don't know if it's correlated at all or it's something completely different. No idea. But it seems to be on a lot of places as well there. So yeah, cool, interesting stuff. And I definitely got interested about like how things are generated randomly by machines who are not supposed to generate
Oh
things
yeah,
randomly.
that's very interesting actually
And
as
there is
well.
this thing
It's
called
like
entropy, which is not the same as entropy in physics, but it's entropy in
maybe it
information
is.
theory.
Maybe it is.
It's not exactly, it shares the same idea as entropy in physics, but it actually has a different definition than the one in physics, and it got really interesting. So, you know, if you guys, curious bunch, if you guys are interested in that and to want to learn more, you know, write in the comments below or in the live chat on the left or the right, or spam us at Twitter, Facebook, website, comments, emails, wherever, and maybe we can do another conversation about how random works.
Yes,
Cool.
hopefully with Chavo because he really wanted to take part into
And
this
Vasco as
topic.
well, who, by the way, also wanted to join today, but he's having, it's midday for him, so, you know, he's working.
It's a meeting. Yeah.
Surprise, surprise. So, thank you very much for joining us. Click like, subscribe,
Thank
and the bell
you.
button.
Maybe let us know if you have used Monte Carlo somewhere sometimes or you want to use it. Yeah. Stay
And
tuned for next week.
yeah, see you
Stay
next
a
time.
curious bunch.
Oh,
See you.
now she said it. All right, bye. Stay a curious bun.